Good afternoon. Good afternoon indeed. Hi, indeed. Hello, indeed. Uh, hello. Yes, good afternoon, Isabella. Hi, Amanda. Hello, Rachel. Hello, Aaliyah. Um, hello, Lydia. Good afternoon. Sorry. Good afternoon, Tania. Good afternoon, Melissa. Sorry. Okay. Okay. This is Crazy Town because we are like here or there or everywhere. We are possibly going to have a not frantic class today. Oh, wait, but more people are going to come. Okay, I'm going to let people come in. Okay, I'm just going to let the other people in. Hello. I'm feeling strangely calm at the moment. I think thanks to you guys. I think I'm usually not calm I'm usually not calm, period. But I'm also usually not calm on the last day of classes. But I feel good afternoon, Farina. And thank you for saying so. I feel like, well, I'm almost actually sad. I am sad. I'm sort of shocked that this is over. But I'm sad in an emotional way, not academically, intellectually. Weirdly, and I know I'm going to be more people coming. I know I'm going to be struck down for saying this. I feel like we're in good shape, all things considered. I mean, I'll tell you what I mean by that more specifically in a moment. Um, but I'll start with some disclaimers. I mean, of course, uh, it's all about progress, not perfection. Always. I mean, of course, there are some things that I would have liked to have said or gotten to this semester that I didn't, and that's true every semester. It might be more particularly true in these crazy COVID Zoomy times. Um, I there are always things that I don't get to say, or there's always more physics to be done. Let me put it that way. And I hope I'm lucky enough to cross paths with some of you in one way or another at some other point in life, and we get to talk about more physics one way or another. Or I hope selfishly that some of you have an opportunity to do more physics somehow or another. I mean, you will whether you want to or not in PChem and in instrumental in some form or another. But in any case, what I'm trying to say is I think that um, we did get to some really big things here in this class, and some things that will hopefully serve you well. More to the point, or more on a more practical note, I think we're going to find by the end of today. I believe you should be in good shape to take a final exam and to get a good grade in this class, which of course is an important thing. Um, um, we are going to mostly, like, I think basically what I'm trying to say is I think whatever larger lessons or larger points or larger themes I want to get across, I have spent the amount of time I wish to try to get them across. And today I'm not frantic to get into any last point or something like that. Today is going to be basically about walking you through what is your going to be or is your final exam. I'm going to hopefully show you exactly what I'm looking for in it or from it. Um, um, I had hoped perhaps to get it to you earlier than I did, but uh, we'll all open, hopefully you all, I think you all have it now. We'll all turn to it in a moment, the document that's in the Google Classroom. And we're going to basically spend today making sure that any questions or concerns or ambiguities or uh, uh, um, the issues that you might not be clear about this document will hopefully be clear by the end of today. And then you'll have a week to do it. And so hopefully there'll even be time for maybe some kind of casual discussion. There are loose ends. Mostly on my side, not on yours. So let me try to address loose ends before we go any further. If you turned in anything in the last week or two, you probably have not gotten it back yet from me. I mean, if it's an old homework or if it was a game assignment, I mean, the last couple of weeks, I certainly have tapered off, fallen off. And so, but please know that I know that a lot of things did come in the last 2 weeks, and that's totally fine. And and I just haven't gotten back to you just because I didn't, they will be marked. They will be credited towards your final grade. It wasn't like you missed the moment or something. I, um, and there's, I guess in some cases, there are some of you who did a midterm correction or something like that, and maybe did it a day later than somebody else or something. So if I never got you back a midterm correction or say something, that then I also know that, and I will at some point in this week while we're all scrambling with final exams. I mean, I think it is a matter of individual loose ends and individual cases, and that's why I probably haven't gotten them, because it's like random rather than systematic uncertainty, so to speak. But just know that I know that there are still individual things and individual makeups and stuff that I do have to address, and I will. But to be as logistically explicit as I can, I mean, so far as I know, with maybe a couple of exceptions or exceptional situations, like you all took a midterm, you all got a midterm back. Some of you did corrections, you got corrections back. You have a bunch of homework, you have a bunch of stuff that you did in lab, you'll be getting a lab grade. So, I mean, I think for the most part, everybody is in like good standing and a good position to just go into this last responsibility that you have toward the course. And that's what we're going to address today. But so let me, again, just try to be explicit about it if I can. Like, hopefully you saw in Google Classroom, hopefully you saw maybe just a few hours ago, in Google Classroom, there's a document that says, "Hear ye the final exam," or something like that. I'm going to do a different screen. I'm going to switch the screens in a moment, and I'll be putting that up. The document I'm talking about, I'll be putting it on the screen. We're going to be like explicitly talking about it again for most of this period. But that thing that is your final exam, like it might say rough draft on it, or it might have said rough draft on it. And that's because, yes, I still reserve the right to find, if I find an error or an ambiguity or something unfair or something like that, I could still update it. And if I update it, I'll let you know. And it will only be for the sake of clarifying something or making something easier or shorter or something. I don't think I'll make it any shorter. But basically, the thing that arrived in Google Classroom this morning is your final exam, and it is due right before midnight on Tuesday, the 25th. I believe that technically is the end of the final exam period. Although that probably ends a few hours before then. But anyway, you have till 11:59 to turn that in. It would be problematic to turn it in any later. If you do run into some situation with that deadline, you definitely want to communicate with me and let me know, or ask permission or something. Like, of course, there can be extenuating circumstances, but you would definitely want to communicate if there are those circumstances, because then there's going to be a major crunch for me to grade all these things and turn them around and get your grades to you in time for when they're due. So please don't mess around with that deadline. But the thing that is in Google Classroom is the exam itself. I'll also admit, in case there was any confusion, when I first put it, for those of you who are like way more responsible than I am, which is many of you, if the second you saw it, you downloaded it and printed it out or anything like that, I have to admit, it turns out that actually when I first posted it this morning, it was totally the wrong document, 100%, just by a complete fluke. I totally put in the wrong document early this morning, and I corrected it in the middle. I swapped out the documents at some point between 12:15 and 1:30 today. So if you happen to, excuse me, so let me just make that, I mean, you'll know in a minute because we're going to go over this thing. If you're so responsible that the minute you got the posting, you printed out or you did something, please be aware that you might even be scared if you saw what was there originally. Like there was a mistake. The document has been swapped out since then. The documents that's there now is what's meant to be there. We're going to talk, I'm going to put it up on the screen in a minute, but that is your final exam. And you'll note when you look at it that a lot of it is already solved for you, and I'm aware of that, or I mean, the solutions are right there. We're going to go over it. We're going to talk about it, even if it, my experience from the other classes, it won't, we'll have plenty of time this period to address anything and everything you'd want to know about this final exam. But let me just say again that the expectations, the requirements, whatever, are the format. It's the same as they were for the midterm, in that I'm telling, the portal is there. You could turn it in anytime you want from here till 11:59 of next Tuesday. You could turn something in and then change your mind and take it out and turn something else in, whatever. And you can do whatever you want to do this document. I mean, you can work together, and I hope you do. You could go on the web, use caution. You certainly can have my solutions right next to you as you do the final exam. Like, that would not be a violation, and it wouldn't be a surprise to me if that's what you were doing. But just like with the midterm, given that that is the arrangement, given that you and I both know that I'm giving you an exam with full open universe conditions, and I'm even largely solving a lot of the exam for you in advance, please understand that your job is to show me understanding, not just answers. Like, I know the answers, and I know you know the answers because I'm giving them to you, at least in most cases, or many cases of the exam. Your job is that you're here to show me that you understand why the answers make sense. To be super specific, and I hate to say this for the 900, like, I hate to be boring on the very last day of class, but I do want to be clear. We did go through this in a big way in the midterm, and many people even worked hard to do revisions. I think it is fair to insist at this point, with this whole arrangement, the document that you're turning in to me, when you finally turn in your final exam to me in that portal that's asking for it right now, the portal that's due 11:59 p.m., when you turn it into me, what you're doing is you're giving me a PDF or a Google Doc. You're giving me one file consisting of many, many pages, and you're giving me one self-contained, self-sufficient, independently readable, independently gradable document. That means, and this is the one, some of you may have to put more effort into what I'm about to say than any other aspect of it. You're giving me a document where you go beat by beat and you say, like, number one, A, given blah, 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 determine blah, 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 or given these facts, the question is, what is the wavelength or whatever? Like, you're writing down the givens and the actual question itself. You, whoever is listening right now, you, the students, you, most of whom did do this, at least ultimately correctly on the last midterm, but I need to, but may have found that this was like a new instruction or a new format that you haven't done in a lot of other classes. I'm saying your job is to make each question super explicit right from the get-go. Like, not just question one, but like, tell me what the question is, what the thing is that you're solving for. And I mean in your words, or at least your font or your handwriting. Like, sure, there's only so many ways to phrase some of these questions, but you're not cutting and pasting my document. Like, let me say that again. Like, this, it was still a little bit confusing to some people by the end of the midterm. You're not writing on my document. I mean, there's no room to write on my document anyway. You are like making up your own blank sheets, like your own blue book, and writing everything out. But you're also not cutting and pasting my questions in there. You're showing me that you know what the question is by putting it in your words. Your words might be super similar to mine. They might. But if they're exactly identical for each question, I think something is probably wrong. Like, you are showing me that you know exactly what the question is, then you're doing the work, and then you're boxing the final answer and showing that you know what the final, like, what piece of information that you've written down is in fact the answer to the question that you will have made super clear up at top. Again, this is super boring, I know, but let me make it clear one other way, because this is where actually, for some of you, this is where the effort will come in. And for some of you, this is where you stand to lose or gain points or whatever. You are giving me a document that I can grade without me having to look anywhere else at anything else. You can assume that I know physics, but don't assume that I remember what each question is. Like, really don't, because it turns out I really can't. Like, of course, I know the basic flavor of the questions, but a lot of the questions are similar from moment to moment in this document. And there's a lot of exams to grade, blah, blah, blah. So you're giving me a self-contained thing that I can just look at and be like, oh, she's doing this right now. Oh, she's doing it right. Oh, she got the right answer. Or, oh, he's trying to do this right now. Oh, doing work. Oh, he did it. He got the answer. Like, I should be able to follow what you're doing without looking anywhere else. That is like part of your job. You're thinking of it as though you were publishing this, you were trying to send this to a journal to be published, where someone reading the article could follow the article without having to read any other article in order to read it. Okay, like that's part of and you're trying to present everything as a readable, enjoyable, clear document. And again, your job is to show each step along the way why why the answer makes sense in the universe and to you. Okay, I mean, I won't overstate that anymore, but part of the reason I'm saying that also, you're going to see in a second when we turn to the document, there are places in this final exam where like you're going to actually think to yourself, what is he even asking for here? Like, he gave us the question, he gave us the answer, he didn't change the numbers. Like, I feel like I'm just copying his solution into a piece of paper and turning it back to him. Like, what kind of test is this? You might feel that way at certain points in the test. And that's fine in a way, but let me caution you two things. One, don't just copy my answers, and not like, if you think the answers make total sense and you're basically just copying them and you don't know what the big challenge is, first of all, the challenge is frame them in a way that gives them context. Don't just copy my solutions, make it clear what they are solving and how and why. Also, literally don't just copy my solutions. Like, again, if you just literally copy my solutions, there's one of two possibilities. Either you're blindly copying them because you have no idea what they mean and you don't actually understand and you never learned the issues and you're just trying to copy them because you know they're correct. Let me tell you that if that's the case, that doesn't work. I mean, again, I'm just going to get this out of the way now so we don't spend the whole period talking about this. But like, if you just try to blindly copy something that you don't understand, it is transparent to the reader that that's what's going on. You won't even be able to do it. Physics is complicated enough that if you try to blindly just copy what I'm doing, just hoping that since it was correct when I wrote it, it'll be correct when you write it. That is, believe it or not, that is like me trying to copy a page of Arabic, which I do not write or read. I mean, I wish I did, and someday hopefully I will, but I can't read or write Arabic. If I tried to copy the symbols of Arabic from one page to my own blank sheet, I could spend all week copying the symbols. But because I don't know what they mean and I don't understand it at all, I would just be struggling to literally copy marks and make them identical. And anybody in the room who knows Arabic would know that I would fail to copy the marks correctly because I'd have no context. It would just be like me trying to copy a painting by Da Vinci. Like I can't paint, so I wouldn't be able to copy a painting by Da Vinci, even if I'm just trying to copy. And I don't speak Arabic, so I wouldn't be able to just copy Arabic and get it right. Similarly, right? So don't just try to blindly copy what I'm doing, because you will copy it wrong, and it will become, or even where you're right, it'll become very clear to me that it's just my thoughts, not yours. The flip side of that is, you all know, once you understand something, even if you're trying to copy it, then once you understand it, you end up, even if you try to copy, you'll end up copying it in your own style, and you won't really literally end up copying. You might copy the first line of how I start something because like you needed that help and that idea because you might not have thought of that on your own. But once you see that line, then you'll see, oh, you'll be like, oh, I get it. And then he divided both sides by 2, and then he multiplied both sides by the wavelength or whatever. And if you get it, then try to be free and just, and try to put down what it is that you get. You'll see that the more you understand, the more your own writing and your personality will come through. And the more you do actually understand, the more you go to effort to actually explicitly show me that you understand, the more that will come through. Like, in other words, the difference is evident between someone who's just blindly copying and someone who gets what it is that they're seeing. So please use my solutions to benefit your understanding, but then please, your test to yourself is, don't write any line down that you don't understand, because if you don't understand it, it will end up coming through and being wrong. Okay, that's like the end of the strict talk. So you're going to turn in this final exam. by 11:59 next Tuesday. Between now and then, if there's an ambiguity or a problem or something in the exam, you are welcome to text me. Please do the usual thing that everybody has been doing all semester of, if you're going to text me, like, first of all, tell me who you are if you've never texted before. But second of all, ask me a concise, direct question that I can answer without getting up and looking at documents. Like, you know what I mean? Don't say, Professor, can you explain question 3? Like, that doesn't put me in a good position to want to answer that text. But you can be like, Professor, you know, or whatever, you know, Yaverbaum, in question 3, it says blah, 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 but I don't know, do you mean this or do you mean that? Like, and then I can answer you. But all right, that's all enough abstraction. I'm going to put this document up on the screen. You'll confirm to me whether you've actually gotten this document. We're going to talk about it. Let me get it. Hang on. Oh, hello. Okay, right. Okay. So the document and hold on, let me also. Oh, whoa. Oh, I guess we don't even need this. Hold on, I'm going to turn this off. Sorry. Okay. Wait. Show active. Wait 1 second. Sorry, I'm going to put this back. Why? Okay. Hello, everybody. So I see everybody. So now let me try this again. Okay. Huh. Well, I don't know why. I'm trying to do this in a way that. The reason I'm pausing right now, and I'm not really sure. Well, the reason I'm pausing right now, it just reminded me of another loose end. As far as loose ends, I hope I don't take all period to do this, but we're about to walk through the final exam together to make sure that you're prepared to take it. So I also want to say, if you tune in and out today or whatever, like this would be one video probably worth checking out. If before you text me with questions about the final, you might want to check out this class that we're doing right now, which will be posted. And that the loose end that I'm talking about is every single class we've done has been recorded and has been posted on YouTube. And I hope you know where to find that at this point. Most of the classes are not just on YouTube, but I link them to Google Classroom. One of the loose ends is I have fallen behind the last couple of weeks. So there are 2 or 3 classes that do exist on YouTube that are there, that are in the 204 playlist, but I didn't necessarily yet link to Google Classroom or update that. I mean, I do intend to, but so just to be clear, like, and this would be one of them, this will exist. If you have any questions about the final, you'll want to check this out. So even if I neglect somehow to put it in the Google Classroom, please know it will be there in YouTube, and they're all there together in the P204 playlist, as are about 1 million classes on the material that might help you with the final. But anyway, all right. So the screen that I'm sharing now, maybe someone could confirm or deny, the screen that I'm hoping I'm sharing right now is the final exam. Again, it's the rough draft only in the sense that I might find errors and have to update it, but it is the thing. Oh, there's someone in the chat. I'm going to check the chat, but I would like, maybe this is what's in the chat. Well, okay, let me look at the chat. Are you, well, I'm about to look. Okay, for some reason okay, I'll look at the chat. Oh, yes. Okay, cool. So your guys are, thank you, Amanda. Thank you, Rachel. Thank you, Farina. So you're confirming that the thing that's on the screen now is the thing that is in your possession in Google Classroom. That's what the yes, it is mean. That's what you're, okay, cool, great. Thank you. Awesome. Okay. So again, to be as clear as possible to anybody who, is there a better way I can do this? Well, okay. This video might be weird, but for anybody who just started paying attention, who just came in, again, this is your final exam. It is called a rough draft just to protect myself, but You could start working on it right now and you would not be wasting your time. And don't look for a new posting or a new portal or anything like that. If I do find errors in this, I'm just going to update. I'll tell you, and I'll just update the document that's in this portal. But this portal that you found it in is the final exam portal. Like, in other words, when we're done today, like goodbye. Don't expect anything more from me. Like, that's it. And I hope that's clear. But okay, you will find as you scroll through this exam, there are only two problems in the whole thing, for good or for bad. There's first a 60 point, well, first there's equations, which you probably won't need most of them. They're just there for formality. And then there's directions. Basically, the directions come down to everything I just said. You got to do the two problems as you have to do both of them, and you have to do them as thoroughly as you possibly can. Okay. Then here's the first problem that hopefully you're seeing on the screen. It is 60 points. It is hopefully largely what you expected, or largely what we've been talking about for weeks and weeks. I'm still going to walk you through it in a way, because there's kind of a twist. It's deep enough that it's going to be the second thing I walk you through. But yeah, the first problem is a 60-point Doppler effect problem, and it consists basically of 24 short questions, each of which is worth 2 points, and then a 12-point thing. I'm scrolling fast because I'm going to go back and just talk about it more in a second. But then a part E that asks you to put it all together and is worth 12 points. Okay, so but basically it's like 2 point, 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 put it all together for 12 points. And I'll discuss that with you all in a second. But that's 60% of the exam right there. And I'll explain this page that I'm scrolling through right now in a moment. Then the second problem is a circuit problem. For some annoying reason, it says problem 3 right now. Actually, that is a complete mistake. And actually, I don't want to waste your time, but I'm going to fix that right now because that is confusing. I don't know why it says problem 3. So bear with me for a second. Maybe I'm going to fix it right on the screen. Weird. Hold on a second. Oh, and I'm still curious to this. So I just fixed it. I don't think that automatically fixes the thing in Google Classroom though. So, but maybe it does. So bear with me. Well, all right, I'll deal with that. Well, yeah, bear with me for a second. I've always been curious about this. Sorry. Sorry. This is really a party foul here, I know, but okay. All right, I believe I just fixed that even on your side. All right, so hello. Okay, and let me know if I'm sharing the wrong screen now or what. But all right, so what I believe we're now looking at on all of our screens is the second problem, the circuit problem. This is something that you've done with Woo and Lab, I hope. Here's a circuit. Couple things just to clarify. Hopefully the symbols that are used here are at least similar enough to the symbols that you use with Woo Hopefully they're not confusing, but you'll notice there's 4 resistors in this circuit. The resistors are called R5, R6, R7, R8. There is no deep reason for that. There's no good reason for why they're not just called R1, R2, R3, and R4. I mean, it's some glitch in the program I used years ago when I made this or something. It's not for deep reasons. Don't attach any significance to it, and it's not meant to confuse you. It's just the case that the 4 resistors are called R5, R6, R7, R8. You're given their values. And the whole problem is first it asks you to get the current, and it gives you the value of the potential across the battery. So it asks you to solve for the current going through each one of those resistors. Okay, that's in effect 4 questions. Like, what's the current flowing through each and every resistor? There's 4 resistors. That's 5 points for each question. And then it asks you for the potential difference, the potential drop, the voltage, whatever you want to call it, across each of those resistors. There's 4 resistors, 4 potential drops I'm asking you to solve for. So it's totally meant to be straightforward. It's 5 points each question. I mean, I'm looking for a total of 8 values, 5 points for the work associated with getting each of those values. That's the whole problem. A couple of things. Number one, even if I didn't give you the answers here, I mean, there's answers here, right? And I'll address that again in a second. But let's even assume that I didn't give you the answers here. I'm asking for 8 different values, 4 currents, 4 potential differences. And of course, if you like really, if you really want to be cool, you might want to try and do this without looking at the answers first, but I'll never know the difference and I won't care. But let's make this clear. I'm asking for 4 different currents. I mean, I'm asking for the value of the current at 4 different places. And I'm asking for potential drops at 4 different intervals. Some answers may certainly be repeated. Like, you might get the same answer to 2 different questions. In fact, you definitely will get the same answer more than one time. That is understood. That is true. That even though there's 8 different questions, you'll get the same answer more than once. But you still have to explain that. Like, you have to explain how you get the answer to each piece. Even if in some case, like, so if you get the potential difference across R7 and you get a number, and then you're going to do R8, you can certainly say the potential difference across R8 has to be the same as the potential difference across R7 because the 2 resistors are in parallel and the potential drop across any 2 resistors in parallel always has to be the same. Like, and that is true what I just said. Like, I'm not trying to trick you. That would be an answer. You can say a thing like that, but the point is that you must say a thing like that. You can't just write down the same answer again and just assume that I know why that is or something, if that makes any sense. Okay, so I am looking for 4. So some answers will take one type of work, like you'll have to do out calculations. Other answers might take an English explanation. That's fine. Or some answers might take more work than others once you put it that way. But no matter what, every single answer certainly has to be justified. And each answer is worth 5 points. If you don't leave the answer blank, sorry, someone's here. If you write anything down at all, you're already at least getting a point, if not 2. And if you write anything relevant at all and show that you know, and this is where it comes in, like if you show you know what I'm asking, if you're like, now determine the current across resistor number 5. And then you like start doing some work or whatever, and then you get totally the wrong answer. Out of the 5 points, you're probably getting 2 at least just for doing that, just for showing that you know what the question is and then boxing your answer, even if all the work is wrong and the answer's wrong. But in order to get all 5 points, you need to do that. Show you know what the question is, show you know what commit to a certain answer, and show work or justification. Now, I know that I've already done that in the exam for you. I have, at least for this problem. Every single answer in there, I think I've justified with some work. Here's the thing. My way is not the only way to do it. The order in which I solved for those currents is not the only order in which to solve for currents. It may not even be the way Professor Wu has done it with you. I think the way I'm doing it is totally logical. It works for me. Hopefully it makes sense to you if you're still trying to make sense out of this and you're still trying to learn it. Hopefully my solution there is still giving you an opportunity to learn this and figure this out before you turn this in. That is to say, there is no shame in using a final exam as a final opportunity to still learn something. That's in fact part of my hope here, that we still have one more week. You're going to understand this, by God, one way or the other. It's totally cool to use my solutions to help make sense out of this. But then, again, don't just copy my solutions, then use them to make sense out of it and then write it your way. B, if you feel like you already understand this at some level, or you don't need my solutions, or whatever, or you can do it a different way, by all means, please do. Even if that just means solving for things in a different order from the way I did, that might be a very wise thing for you to do if you're at all in, if you're looking at this exam and you're like, well, he's given us the answers. Like, what's even the challenge here? Like, or, how do I not lose points? I will tell you, if you just write down my answers and you don't package them correctly, or you don't justify them, or you don't show what questions they're going to, you could lose points, even if it's the right answers, especially because I'm giving them to you. But conversely, if you're like, I do get these answers, and like, I'm actually, if some of you might be like, you're insulting my intelligence, Yaverbaum. I mean, for God's sake, I've been working in this course all semester. I want to actually show you that I actually did learn something. Then by all means, then solve these questions in a different order from the way I did, or do a slightly different tech. I mean, it really does make all the difference. Whichever one you start with, there's a million different ways to do this, and whichever one you choose to start with will dictate the logic of all the other questions. So please, by all means, answer these questions any way you want that makes sense to you or makes sense to Professor Wu. And then you can at least just use my solutions as a check to see if, to make sure that by the time you hand this thing in, that you're handing in the correct answers. I am not changing these numbers. This is not hypothetical. This circuit problem is the circuit problem, even with these numbers as is. So again, in a way, the challenge to you is to show me that you get it, not to show me the correct answers, because there they are, okay? But hopefully the circuit won't be too stressful, but that's why I'm going over it first. I mean, hopefully it's straightforward. It's 8 things you're looking for, 5 points each thing, end of story. So that's the circuit thing. I'm going to pause for a second. I don't know if my tone of voice is kind of like not the tone of voice that I'm hoping for today. So before I go on to explain the slightly more complicated thing, which is the Doppler effect problem, please, 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 no matter what tone of voice I have right here, even if I'm making it sound like this is all straightforward, this is our last day. So if anything is unstraightforward to you, please put it in the chat, and please put in the private chat if that's the more appropriate thing. But even if your question is still like, when's this final exam due? Like, I do feel like I'm making that as clear as I can, but I want it to be 100% clear. And today's our last chance. So look at the circuit problem. I'm going to pause for a second again. It's not meant to be a trick. There's nothing about it that's meant to be a trick. But if there's anything tricky or confusing about it to you, you would probably want to find that out right now and tell me right now. So I'm going to pause for a second. But that's the deal with the circuit problem. All right. And like, here's just a dumb example. You see on page 9 at the bottom where I'm trying to help you. So I am still trying to teach at this point. I'm trying to help you, right? But so I write this paragraph at the bottom of page 9, like, it is crucial that you're comfortable with the reasoning behind this certainty, blah, blah. More than not, a person who feels hopelessly stuck, blah, blah, blah. Okay, that's obviously me talking, and probably talking too much. Believe it or not, there would be some people who would blindly copy that paragraph I mean, I don't want to insult anybody in advance, but let me tell you, it wouldn't surprise me at all if someone who's half paying attention right now or not, or whatever, it won't surprise me if I get some exam from someone where they actually copied that in to their answers. And you don't want to be that person. Don't copy that into your answers. If you see what I'm saying, like, that's me trying to help you. That is not an actual answer to the problem. And so even that, like, even just leaving that out shows that you're at least understanding this communication that we're attempting to have, you and I. Don't blindly copy what I wrote in the solutions. Use the solutions to help you understand. I hope that makes sense. But really, like, and I hope maybe some of you are even laughing inside to the possibility of imagining someone actually copying that in and handing it back to me, but somebody will. Okay. And that wouldn't be cheating. And I couldn't like, I can't literally take off points like right at that moment if they do that. But it sure is a sign that something funky is going on in their exam if they do that. And it sure would make me look at the rest of it quite critically, if you follow me. But all right. That's just like obnoxious on my part to even say. But okay. But now we go to the possibly more interesting thing. I promised you a Doppler effect problem. We spent a lot of time on the Doppler effect. I'm scrolling back to the beginning again. Stop me if this is a weird, I'm not used to doing screen share this way, so I can't even see if you're chatting or not. In fact, I really don't like this. I may switch. I really don't. And I don't know how this is going to come across in the video too. Oh, wait, there is something in the chat. Hang on. Oh, excellent catch. Wait a second. Okay, wait a minute. In the private chat. Oh, and I'm glad that's why we're doing this right now. Wait, did I do that? Okay, there's a thing in the chat that I will read out loud in a minute. I mean, not the person's name, but oh my God, wait a second. Yes, that's a really good catch if that's true. Hold on. So someone's raised a question about the circuit. I'm just scrolling. Oh. Yes. Really good point. Okay. This is why I'm glad we're doing this right now. Okay, thank you, private chat person. So I'm back to the circuit thing for a second. If you scroll to page 11, as I think I'm doing on the screen, right? Okay, right. There is like a typo here. Will fix. I might even fix in the middle of this class. In fact, I think I'm going to try to fix it in the middle of the class if I can. But yes, there's a typo. Like okay, and bless you or something. Let me back up and say again. I made the resistors. The names of the resistors are R5, R6, R7, R8 for no good reason. They just are. So then your job is to solve for the current going through R5, the current going through R6, the current going through R7, the current going through R8. And then your job is to solve for the potential drop, the potential difference across resistor 5, resistor 6, resistor 7, resistor 8. And those are the only labels that should be throughout my question and your answers. It is true, as private chat person caught here, when I do the solution for you here on page 11, and I show you how to get the answers, then accidentally I ended up late. I solve for potential difference across number 5, but then in my boxed answer, I stupidly somehow called that potential number 1 rather than 5. That is a typo. That is not meant to be a trick. That is a mistake. That is confusing. There is no potential 1 or resistor 1 in the whole problem. It should say, so right in the middle of the screen here in the boxed answer that says delta V1, it should say delta V5. And that error sort of seems to permeate through the rest. So let me see if, can I fix this? What time is it? Wait, this ends. Okay. I'm going to try to fix that and re-upload the document, but I'm not going to try to fix that right now. I have a feeling that's going to get me all in a rabbit hole. Let me see. Actually, hold on. Give me a second. I will try. But thank you, private chat person. Can I just get? I'm going to try to fix this for a second right now. But if I don't fix it right now, then I'll fix it right after class and re-upload it. But can I get, other than the person who just put that in the private chat, could I get anybody to publicly affirm that they just heard this correction that has been caught? I mean, can anybody affirm or confirm that you understand that wherever it says delta V1 or 2 or 3 or 4, it really should say 5, 6, 7, and 8. It is a typo that it's saying 1, 2, 3, and 4. And can anybody confirm or deny that they hear this? That's scary. All right, I'm going to try to fix this right now because I don't. Oh, yeah. Okay. Thank you, Miles. All right. Phew, thank you. Okay. Thank you, Rachel. Okay. Awesome. All All right, let me take 2 seconds to see if I can, how hard it is. Oh. Right, okay, but okay, and there's also a good question here in the private chat. Give me a second. Let me see if I can fix this. If I can fix it easily and fast right now, I'm going to, and if not, I'm going to re-upload it later. But hold on. But then there's also a good question in the private chat. I do see it. Don't let me lose sight. Hold on 1 second. Oh, and there's another one in the chat. Oh, okay, thank you. Okay, but yeah, don't let me forget. All right, hold on. Let me just see if this can be fixed easily. Oh God, this is going to be annoying. PDFs for heaven's sake. Yeah, this is going to be sort of finicky. All right, I'm not going to fix this now. But yes, all the answers should just be like in reference to 5, 6, 7, 8. There's no 1, 2, 3, or 4. And again, that's for no good reason. It's just the way it is. And I'm going to assume that since a couple of people confirmed that they heard this, I want to thank the private chat person again. And yeah, that's a good catch. I will fix that. Now, and let me go back to, okay. Now, question in the private chat also. And it's a fair question. It's sort of what I am. The question in the private chat, which is sort of what I'm sort of spending this whole period trying to answer. So someone wrote, I'm going to read the words so someone wrote, and I think this is a good faith question. Professor, I'm a bit confused with the length we have to go to in order to show how we derive the solution if the solutions are given. Are we required to actually explain in words what we did with every problem? Okay, my answer to that is you are required to show that you understand. Sometimes it can be words, sometimes it can be equations. It's not always both. Ideally, it's both. But the best rule of thumb I can give you, and yes, I know it is a little confusing that I'm like giving you solutions yet asking for them right back. And you'll see the instructions are slightly different for the Doppler effect problem too. So hopefully there's something in this exam for everybody in a way. But when in doubt, here's the rule of thumb to follow. Because yes, I'm giving you the solutions, yet I'm asking for them from you. So the best thing you can do when you're in doubt, like if you feel that you understand how I got an answer, but you're unclear as to what to give me, which is the good position to be in. Like if you really feel like I get what's going on here, but I'm not sure I get what I'm supposed to do to get an A on this exam, then first of all, one thing I could just say is try to see, if nothing else, look at the answer in my solution and then try to write your solution without looking. Like even if you have it right next to you, even if you have mine next to you, just try to write it without looking. And you can still then go back and check that you didn't make a mistake or whatever. But as long as you try to write it without literally copying, you're going to find that automatically, as long as you understand it, and really that's my best advice to everybody. Try to do this thing without looking, but I don't mean under crazy test conditions. I don't mean put my whole solutions away and see if you can do this whole exam from memory without looking. I mean, that would be great. I mean, I would be totally impressed if you did, but I'm not even saying you have to do that. I'm just saying for any individual question, when you sit down to write it out for me, just like look at my answer first, then turn your head the other way and see if you can write it out without literally copying it. And then go back and check and see how you did. The fact is, if you actually get what I did, and since you have time to check and make sure that you didn't leave anything out, you'll find that if you actually understand what I did, but you don't look at what I did while you're writing, you're gonna almost automatically write it your own way. That's part of what I'm saying is like if you're already up to thinking, I get what's going on, but I don't get what he's asking for, you're probably in good shape. It's the people that think that they're supposed to just literally copy what I wrote down that are going to get themselves into trouble. So in other words, try to write from memory what you think I wrote down. And even doing that, you're going to find it ends up being different. But also to take a slightly step further. And I know this is a weird kind of test, but these are weird times. And I'd rather do this than other things we could do on Zoom. The other thing is, the more you can just try, to use your own words or different words, all the better. Or when I just gave a solution in equations, you try to use some English. Or if I wrote a lot of English, try to use different or more concise English. Or if I wrote a lot of English, but you think you could capture in equations, do that. Just, you're not trying to make up new physics. You're not trying to give different answers. You're not trying to be original that way, but you are just trying to originally express your own original, authentic understanding. So, I mean, there's a lot to be said for just try to take what I'm doing and just put it in your own words. You'd be amazed how far that goes in forcing you to understand and forcing me to see that you do understand. But when in doubt, if that's too tricky or too weird, or it makes you feel unsure, then when in doubt, what I'm really saying to all of you is look at my answers, like look at the solutions, see if you follow them, and then just try to write them out without looking. Put another way, by the way, the one thing I really think you all should do is do a rough draft and then do a final copy. I mean, especially since I am giving you all these resources and everything. I mean, you want your final, if nothing else, just think of your final copy, your exam, as an opportunity to make your responses as clear and as beautiful and as easy to read and as, think of it in other words as you're trying to teach, you're teaching 7th graders physics or whatever. Just like, you might glean your understanding from what I'm saying, but that doesn't mean what I'm saying is necessarily the most concise or the most direct or the most helpful way to say it. Once it clicks in your mind, say it your way. I mean, for real, that's the best thing. But again, that will happen more automatically than you think, as long as you are really being honest with yourself and making sure. I mean, the minimum standard is do not write anything down that you yourself do not understand. Imagine that I would oral exam you on this after you turned it in, for example. Like, that's not going to happen. But like, imagine that I would like bring you up in front of judicial court or whatever, and I'd be asking you to justify vocally what you wrote down. As long as you could actually do that, then I bet the way you write it down is the proper way. I mean, and I'm not trying to scare anybody, but that is a fair question in the private chat. Okay, but also, we have 20 minutes left. If for any of you who thinks you do understand the circuits and you do see how this problem is done and you don't think it's that bad and you're just a little nervous of like how I'm going to grade it or whatever, don't be too nervous and you'll get your opportunity here on the other problem. Okay, I'm going to switch now. I'm going to try to switch. So confused how the screen sharing is working. But I'm going to switch now to the Doppler effect problem, which is a little bit more challenging and a little bit more thick. Here's what's going on in the Doppler effect problem. It is, well, okay, so I'm scrolling. All right, so here's a Doppler effect problem. I'm giving you a situation, and as I sort of promised, you're going to walk through a number of different cases of one situation, and you're going to get final answers for frequencies for each of the cases, and you're going to compare and contrast those answers. And when I say different cases, I mean you're going to walk through a source moving at a certain number. Wait, let me back up. Remember, no matter what kind of Doppler effect problem it is, no matter what Doppler effect situation it is, the basic deal is what's known is the frequency as measured by the source, and you are trying to find out the frequency as measured by the receiver. Like that's your ultimate job in each subsection of this problem. You're always trying to find out what's the frequency as measured by the receiver, given some frequency as measured by the source. And I'm organizing the questions so that in order for you to get that final frequency, you're going to walk through the steps that we've done every single time in class. So let's walk with you. All right. So, but you're going to look at the different cases and you're ultimately going to come to a conclusion about the different cases. Here's how it works. Okay. So it says, so I'm on page 5, problem 1, resolution of the Doppler effect, 60 points. For this problem, use all the facts, the values, the solutions, and the conclusions found on the following sheet. Okay. And you're going to show all work, and you're always going to begin your own words by explicating the question, blah, blah, blah. Each piece is worth 2 points. Okay. Part A says, assume waves are transmitted from source to receiver. Assume the source is receding from the receiver at a speed of 80 meters per second relative to the air. Assume that the receiver is stationary relative to the air. Okay, what am I talking about here? As it says, I am asking you to refer for this entire Doppler effect problem. You're going to refer to this page right here. Everything is on this page right here. This page has everything you need to know, including solution methods, it has all the facts, it has solutions, it has final figures. But as you can see, looking at this sheet, well, let me back up. Let me put it this way. If you know what's going on with the Doppler effect, if you get the basic idea and you've been practicing in class, then you're going to find that everything you need in order to answer the questions on the exam is right here on this sheet. However, as you might notice looking at the sheet, if you're not haven't been following in class, or if you don't take the time to actually sit down with your notes or with the past videos, whatever, if you don't sit down and try to actually make sense of the Doppler effect as we've been talking about in class, then this sheet is an intimidating, crazy mess. And I'm not on purpose, but it is. Like, this sheet has so much on it that I could barely make heads or tails of it if I didn't know what to look for and how and why, right? I mean, it's sort of like a table that way. And I'm not doing that to be tricky, but I'm saying, I'm saying all the numbers you need are on this sheet. Specifically on this sheet, what we're presented with is a source and a receiver. And again, I'm going to walk you through in more detail in a minute. But what we're presented with on this sheet, the sheet that says Charlene's Doppler debut, what we're presented with is a source sending out some stuff to a receiver. And what it's trying to say, and it's looking at a number of different cases here on the sheet. But what you'll find as you look more and more, and don't try to take it all in at once, obviously. I mean, you're meant to look for things you need on this sheet as you need them. But as you look at it and as you look closer, you'll see that over and over and over again, no matter what case you're looking at, no matter where you're looking in the sheet, the velocity of the wave relative to the air is always 340 meters per second, just like the speed of sound. Like, it's not meant to be a trick, and it's no different from what we've been saying in class. Everywhere on this sheet, the given speed of the thing, of the motion relative to air, is 340 meters per second everywhere on the sheet, and you will use that in your questions. Also, you'll notice on this sheet, like if you look all the way to the top left, you'll see sound, it says in blue, sound waves emitted at a source frequency of 500 hertz through a medium of air. And it says the speed of sound relative to air is 340. So it's not meant to be a trick. I am saying that no matter what part of the exam you're on, I mean, no matter what sub question you're answering, what's given here is that the frequency of this stream, the frequency according to the source, is 500 hertz. Like in class, we often used 440 because that's a middle A on a piano. So I'm just shaking it up a little bit and doing a note that's a little bit higher than that. I'm doing a 500 here. It's also a number that's easier to work with. So here it's 500, and you're going to use that 500 everywhere in your calculations on pages, on the prior pages. Okay. Everywhere. But now I'm scrolling back. So like 500 is a given number, and it's not a trick, and it's not an arbitrary example. It's like, it is the number 500. And 340 is a given number, and it's the number of the speed. It's the speed of the wave relative to the air. And as long as you know what that means in Doppler effect problems, then you treat it that way. But now you'll notice, so let's look at part A. It says, assume waves are transmitted from the source to the receiver. Okay, so we're talking about waves, and that means we're talking about any of the cases, any of the three cases that it's mentioning on the top row of the sheet. And then it says here, assume, so I'm looking, hopefully you can see this, I'm looking at part A of problem 1. It says, assume that the source is receding from the receiver at a speed of 80 meters per second relative to the air. Assume that the receiver is stationary relative to the air. So I'm mentioning the number 80 there. I'm mentioning the number 80 right there. I didn't mention any other numbers right there. In the other class today, people raised the question that confused some people. Like, why am I specially mentioning 80 right now, but I didn't mention any other numbers? Does that mean you're only allowed to use the 80 and you're not allowed to use the other numbers? Like, what's up with that? It's not meant to be confusing, but it's a fair question. And I hope people are listening. Let me address it right now. I am saying all the numbers that are given on that sheet are what you're using here. This whole Doppler effect problem is in reference to that sheet. That sheet not only contains givens, but it also shows you how to solve. But the reason I'm specifically mentioning the 80 right here now, even though the 80 is actually written on that sheet, the reason I'm specifically mentioning the 80 here is that if you've been following the Doppler effect problems, if you've been with us in class, you'll realize that like that number, the number that right now I'm saying the speed at which the source is receding from the receiver, okay, that number is 80 all over the sheet, but depending on which case you're doing, then that 80 refers, like in this case right here, that 80 refers to what the source is doing relative to the medium. And it's saying the receiver is sitting still, i.e. going 0 meters per second relative to air. If you look at a different case, like later on in your test or later on in the sheet, if you look at another case, like where the receiver is the one doing the motion, then it would be the receiver that's going at 80 meters per second, and the source would be going at 0. In other words, I'm just trying to be super explicit here that the numbers in question, the numbers that we're talking about are 340, 500, 0, and 80. I mean, I can't put it any more clear than that. Like the numbers that this whole problem is revolving around are are 340 meters per second, 500 hertz, 0, and 80. But sometimes it's one object going 0 and the other object going 80. Like sometimes it's the source going 0 and the receiver going 80. But in another case, it's like the source going 80 and the receiver going 0. Furthermore, if you've been following this and you understand, one of the nuances also is depending on what case we're talking about, if we're talking about receiver approaching, then we might call that number positive 80 when we're doing out our solution. We might make that a positive number. But if something's going in the other direction, we might call that number a negative. No matter what, in the exam, I'm saying the speed is 80. But so why, in other words, the reason that the 80 number is being mentioned, the reason you're being reminded of the 80 number here in the questions is because the 80 number is being used different ways in different cases. And as is the 0, frankly, like whenever I use the word stationary, I mean, that means 0. So I'm trying to be as clear as possible here, which one is 80 and which one is 0. And I'm trying to tell you in English or signal you in English, like which direction to make the 80 go in. But it's ultimately up to you to assign negative signs when appropriate and assign positive signs when appropriate. That brings me to the next. So hopefully so you are meant, I forget, is Jennifer in this class? Hold on 1 second. 1 second. I don't know. 1 second. 1 second. Sorry. No, Jennifer's not in this class. Okay. So, I mean, so this is just one of many things where I promise you, I am not trying to be confusing. I'm trying to be as unconfusing as I can, but physics is confused. Physics can be complex. So the more you get what's going on, the more you'll get what's going on. And when in doubt, always assume there's two different ways to interpret a question, or there's two different ways to interpret a number, assume the simpler interpretation. That's better for you and better for me to assume to assume the simpler interpretation. But anyhow, okay, you use the numbers. Let me go back to the screen share if I'm still there. Okay, so, but now so in part A, it says assume waves are transmitted from source to receiver. Okay, assume the source is receding from the receiver at a speed of 80. Okay, now this is the other hook of this. And again, for those of you who don't just like want to copy solutions blindly or feel like that's a weird thing to do, please be aware here, you're not going to be copying solutions blindly here, because everything I did for you on that sheet, I did out every case possible, including a base case where nothing happens at all, just almost as a control to show you. I did all these things out, but everything that's on that sheet are things approaching. Everything on the sheet is what happens when things approach. Like I'm getting answers for you based on approach. What I'm asking you right here in the exam is to do cases where things are receding, not approaching. So here, you can totally use my methods of solution. They are there on the sheet. You could still be learning my methods of solution right up until the bitter end. But please note here, you better be careful with the numbers, because the answers you're going to get here are not the answers that I'm getting there. I hope this is clear. Let me say this again. What I solved for you right there on the sheet is what to do in the case of approach. If you follow the logic and you get what I'm doing, then you'll see that to do the case of recede, oh, you're going to follow all the exact same steps. Oh, yes, you're going to follow the same logic, the same reasoning, and you're going to see a same pattern of final answers. But your answers will be different because there are going to be places wherever I put a minus sign, you're going to put a plus sign. And there are going to be places wherever I put a plus sign, or the other way around, you're going to put a minus sign. And if you're understanding what you're doing, you'll know exactly where to tweak those. If you see the logic, you will see where to adjust positive and negative signs. Like, but if you don't get it, then you won't get it. Your answers that you finally get to answer this should follow the same pattern as mine. Like you'll notice on my sheet, in the base case, all the way to the left, in the base case or the control, if you like, which we never did out in class because I always said it was self-evident, but I'm trying to show you here just so you can see everything. If we sent waves from a source to a receiver and nothing moved through the air, like the source was just sitting there in the air and the receiver was just sitting there in the air, then whatever the source would send, or whatever frequency the source would measure, even if you go through all the steps carefully, and you don't make any biased assumption, you'll find that the frequency received, the frequency as measured by the receiver, will be exactly the same as the frequency measured by the source. So in this case, if the source measured 500 hertz and you carefully walk through all the steps where there's no motion at all of either object relative to the medium, then you'll get that the receiver receives 500 hertz frequency. It's just there as a control. But then if the source moves in, the receiver will measure a higher frequency than 500, as it shows here on the sheet. The receiver, and it's pretty dramatic. I intentionally chose 80 here in my example, whereas we used 40 in class, just so I can make a more dramatic difference. So there's not even an issue of rounding as much. You see that if the receiver, you see here in the second column, if you look closely where it says case 2W, source approaches. 2 meaning it's case 2 now, we're having something move, we're having the source approach, and it's W because we're looking at waves. If you look at that, you'll find that when the source moves in, the waves received by the receiver are received more often than they were sent. The receiver receives a frequency of 654 hertz, and it's all solved for you right there. Now, you're going to solve for what's happening if the source is moving out, not moving in. So you should get an answer that's a lot less than 500, I'm telling you right now. In fact, if you think that you should get an answer that's about 154 less than 500, you're probably right. And that's probably a good intuitive check to make sure you've done it correctly. You'll probably get an answer around 346 hertz. I mean, make sure, I'm not guaranteeing you that, but if that's what you're thinking, you're not crazy. But then notice if you do source, if you then do over to the right hand, to the third column of this sheet, to case 3W, the receiver approaching, you notice there, I again got a frequency that's higher than 500, but I didn't get the same frequency as I did if the source was approaching. I got 617. You'll get a number that presumably, hopefully, if you're doing it right, is probably 117 less than 500. You should, when you're doing when you're doing receiver recede, you should get a number that's less than 500, but not the same number as you got a moment before that. Okay, so again, the solution methods are right here, but I've solved it out for approach. You're going to solve it out for recede. It's not that big of a deal if you know what's going on. And again, the sheet hopefully is super useful if you know what's going on. But if you don't know what's going on, this sheet is a nightmare, I would think. I mean, there's a lot written on the sheet. Now, I know we have 5 minutes left. What happens at the bottom of this sheet, I hope you see, is the thing I keep alluding to in class conceptually, but here it is finally numerically drawn out for you. The bottom of the sheet, it shows you what would happen if we had a stream of particles rather than waves, which is ultimately the punchline of this whole thing. I'm showing you how to solve it. I'm showing you what would be the difference. And the difference in the solution method would be, even though there still might be air between the source and the receiver, the air doesn't play any significant role anymore. The bullets that would come, so I'm doing it for bullets now. Again, in the base case, if I shoot 500 bullets per second and I'm just standing there and you're just standing there to receive them, and you're going to receive 500 bullets per second, whether it's waves or bullets, no matter. But you see here, if I'm running toward you while I fire those bullets, then you get bullets a lot more frequently than if I weren't running toward you. In fact, you get a familiar number. You get 617 instead of 500. Now, I mean, we're talking about bullet frequency now rather than wave frequency, but we can still solve the problem. Notice though, if you're careful in solving, if here, and we're just about done, I know there's 4 minutes left, but what I'm trying to show you here in the solution method is that the difference is if you were throwing bullets don't come out at a speed that's fixed to the air. Like the air could still be there, but the air is not having any impact on the bullets. The bullets come out at a speed that's fixed to the source. Like however fast the source shot the bullets, that's how fast they come out relative to the source, just like throwing a baseball or whatever. And so if you bear that in mind and you follow my solution method, you find that in the end, whether the source moves in or the receiver moves in either case, you get a received frequency of 617. Like the big punchline here is that, and this is very subtle, again, in both cases of bullets or waves, you get what looks qualitatively like a Doppler effect. Like you'll receive things more quickly than they're sent if someone's moving in either case, waves or bullets. But, and similarly then when you do the numbers in your exam, and there again, you could be learning from my method, but you're doing your own numbers and you better do it right. You're going to find if you do it right, if you do it carefully, that whether the source comes out or the receiver comes out, either way, we're going to get the same number for the frequency of bullets received. And it's going to be a number lower than 500. And it probably will be a number like 383 or something like that. I'm not guaranteeing it, but something like that. But whatever it is, you should end up getting two numbers that are the same when it's particles and two numbers that are different from each other when it's waves. And then that finally brings to the final punchline in part E. I hope that's clear. Like, so there you are following my methods. You can use my solutions, but you're using my given numbers, but you're going to get answers that are different from mine because you're doing the spread out case. And what I've just like drafted for you is the spread in case. And finally, then in part A, and I know we have like 2 minutes left in part E, which is worth 12 points. You have an opportunity to really go to town here. In part E, really show me as best as you can that you get this. What it says specifically is it's asking you to just back up and summarize what you just found. Like use your own words and your own numbers. When it says your own numbers, it could be the numbers that you just crunched up in the prior 2 pages. I'm not saying you have to make up a whole new fresh set of numbers, but some of you might want to really make a point. If you really want to show me, you really know what's going on, you can make up a whole new set of numbers, either numbers that are faster than the speed of sound, if you want to make a really cool wild point, or numbers that are more divisible by the speed of sound. Like you might make a frequency of 340 so that your numbers are super easy and clear to work with. You can make up totally fresh numbers, or you could just use the numbers that you just worked with up above. But you are now in part E, using your words or your pictures or somehow your voice to show me that you get how we could use this Doppler effect to actually investigate an unidentified stream and find out whether it's made of particles or waves, because that is the ultimate real question. I know we have like 1 minute now, but remember what this is all about in the end is it's all about the fact that in the end, some things exist. Like electrons exist as particles, they are things, but other things like sound does not exist as a thing. There's no such thing as a sound thing. There's no such thing as a sound particle. Sound moves as waves no matter how microscopically we analyze it. And one way we can know that is by doing this test, this Doppler effect test. That's how we can know even something new, something brand new, or something so microscopic or subatomic that we've never seen it before, or something so elusive and crazy like light. One way to tell whether it's actually a stream of actual existent individual items or whether it's just a phenomenon, a behavior. One way to know is how it manifests itself in frequency measurements under a seeming Doppler effect like this. So you'll get, if you just show that you understand the question and you start working out an answer, you're going to get like 3 to 4 points out of those 12 just for showing that you know what the question is and giving me an answer. But you'll get all 12 points if you really take that opportunity to show me that you've really learned something, that you really can do something that's not just copying or whatever. And those of you who are itching to do that, that's your opportunity. And please do. Okay, it's 4:20. I would like. I'm going to turn off the screen. I know we're done, but I want to just say I've really enjoyed having you a lot. I hope I see you guys in one way or another down the line. If any of you needs recommendations or would like to do research or something, I would love to stay in contact with you. And I hope you end up back on John Jay campus at some point and somehow. I'm here to say, as soon as you say goodbye, you're gone. And you can text me if you have any questions about the exam, but I hope it's sort of clear now. I would love to see your video before you say goodbye. Any of you or all of you have the guts. I mean, I'm saying goodbye now. I'm done. And as soon as you say goodbye, you're done. But if you want to show your video for a second to say goodbye, that would be nice. But thank you so much. I'm done. And go on to your next class. Thank you so much. Okay. And yes, have a great summer. Oh, and there you are. Oh, awesome. That's awesome. I was hoping you'd do that. That's great. You better do research or something. That's awesome. Thank you. And you get it, right? Or whoever's still there, right? Oh, whoa, why did Roblox just come up? What's going on? They're still there. Okay. Why? I can't, I don't even understand this video. And I'm not holding anybody.
Thank you, Professor. Have a great summer.
Thank you very much.
Have a great summer, Professor.
Great summer. You guys, thank you all very much for always saying hello and goodbye. Have a great summer. Okay.
Bye. Thank you so much, Professor. Have a good summer.
Thank you so much. Seriously. Bye. And I'm just waiting till everybody goes just to be formal, but thank you so much. I mean, you don't have to wait for me. I'm waiting, but thank you so much, guys, and good luck. Or okay, you guys are good. Thank you guys so much. You guys are good. Maybe Melissa. Oh, okay. Oh, that's not. No, thank you. I'm actually sad too. I'll miss you. I think you guys have been great. That's a very nice thing to say. I hope you're not too sad. I mean, that'd be crazy. But and I will see you again. But that is very nice. Wow. Okay. And I hope you get back to campus somehow. But okay, cool. Okay, thank you for everything. Seriously. And if I really appreciate it. You guys have been particularly great. You've made this much more livable than it could have been. So okay. And I'm not thank you very much. And I'm not trying to kick you out, but and I guess in a minute I have to let the other people in. But if you're good, I'm good. Thank you so much. Okay. Awesome. Thank you. So I see. No, thank you. You too. Enjoy the summer. That is great. Thank you. All right. Awesome. Okay. But you're good, Ingrid. But thank you very much. All right. I'm gonna say goodbye.